Hi, good morning, student. Today we have to continue the same exercise. So many problems we have done regarding the continuity and point of discontinuity. And one revision class also I have taken. Today I will continue the same thing. Look at this question. F of x is equal to modulus x plus 3 if x is less than or equal to 3 minus 2x when your input will be lies between minus 3 to plus 3, 6x plus 2 when x will be greater than or equal to 3. Here, just we may observe that our x will be less than 3, means minus 3 to infinity, one part. I will show roughly here. I will show roughly here. This is our x and x dash. Hmm? Here x is less than 3 means 1, 2, 3. Here we can take. So, this part. So, here will be 3. 3 to minus infinity, we have to check it whether our function will be continuous or not. Also, I can extend this one. Minus 3 to plus 3. Sorry, x is less than 3. It will be minus 3. I'll rewrite this one. I have taken 3. That's why. Minus 1, minus 2, minus 3. Hmm? So, minus 3 to minus infinity, we have to check it. Minus 3 to plus 3, we have to check it. 3 to plus infinity, we have to check it. So, like this, they have given. It means that minus infinity to minus 3, this is the one place. Here we have to check our function will be continuous or not. Minus 3 to plus 3, here our function will be continuous or not. Here 3 to infinity, whether our function will be continuous or not. Clear? In earlier questions, we got at particular place, but here they not given any particular point. Just points are not given means in real numbers set we have to check it. Those real numbers, how they are splitted according to their domain, less than minus 3, minus 3 to plus 3, this is greater than plus 3. It's clear whether we have to check it. So now we should go by first case at C. Clear? Some arbitrary point I will take in that interval, which interval x will be less than minus 3. C, which is less than minus 3. This is case number 1. Be careful while writing. Minus 3 to minus infinity, now I am going to check. So that limit of f of x as x tending to, what is that? X tending to c. Who is c? C will be any one value which is lies between minus 3 to minus infinity. It may be minus 4, it may be minus 5, it may be minus 100, it may be minus 3.01, like that. It can be any one value which is belongs to the open interval minus 3 to minus infinity. Now, this is limit of, how much is there? Modulus x plus 3. X will be tending to c. Modulus x is already, we know that it is a continuous function everywhere. Clear? So, by substituting any one value from minus 3 to minus infinity, you will get it any indeterminate form like 0 by 0 or 0 power 0 or anything. No, it's not possible. We know that it is continuous everywhere. So that's why directly we can substitute, that is modulus of C plus 3. Clear? So now this is our required result. Either modulus of C also we can write it. Modulus x below less than 0 is there, no? At that time minus x minus of minus will be plus. Like that also we can write it. As well you should keep it. Now this will be f of c. F of c is how much? Mod of c plus 3. Therefore, we write it limit of f of x as x tending to c equal to f of c. Everywhere value will exist so that the function is continuous. Therefore, function is continuous continuous in the interval minus infinity to minus 3, or simply we can write it, the function is continuous at c less than minus 3. Like this also you can write it. This is the one case. Now the second case, case number 2, exactly at c is equal to 3. Now that arbitrary constant becomes 3. 3 means, sorry, minus 3. Minus 3 means here we have splitted. When we are going to take left deleted neighborhood of minus 3, for that one relation they have given. When we are choosing right deleted neighborhood of minus 3, for that another relation they have given. That's why compulsory at this case we should find left limit as well as right limit. Here some basic will have. Mod x is a continuous function, 3 is a constant continuous function, sum of two continuous function will be always continuous function, so that there is no break in that graph. But here two relations are splitted according to their input. Left deleted neighborhood of minus 3, right deleted neighborhood of minus 3. At this case, what we can do? Step number 1 should find left limit. Left limit representation is limit of f of x as x tending to minus 3 minus. Like that we can write. Afterwards, we may write it, that is limit of x tending to minus 3 minus. Minus 3 minus means left deleted neighborhood of minus 3. Left deleted neighborhood of minus 3 means minus 3.0001. At this case, which relation they have been given? This mod x plus 3. That we can write it. Modulus x plus 3. Close it. Now substituting this value. If we substitute it means what we will get it? That is limit, we can substitute it is totally free from indeterminate. So modulus of minus 3, it would be plus 3. It is 3 plus 3 becomes 6. What is your left limit value? 3 plus 3 is equal to 6. Now I should go for right limit. Right limit is nothing that limit of f of x as x tending to minus 3 plus. This is limit of f of x. Your input will be minus 3 after. Minus 3 after means to minus 2.9 bar something. Right deleted neighborhood. Minus 2.9 bar lies between minus 3 to plus 3. So this relation we can use minus 2x. That is x tending to minus 3 plus. Now, this is also polynomial. 2x minus 2x will be a polynomial. So, it will be totally free from indeterminate. For every real number, it will give some output. So that we can substitute here minus 2 into minus 3. It would be plus 6. What did we get? Left limit is equal to right limit. It means that limit exists. Like that, limit exists. One more case we can check it, f of a. That is value of the function. F of each bit point minus 3. F of minus 3 means equal sign they have given. When x will be minus 3, you can choose this relation. That is modulus of minus 3 plus 3 It is 3 plus 3 is equal to 6. So, left limit will reach to right limit at the place 6, and the value of the function will also exist 6. All these three must be same, means if we constructed the graph from at x equal to minus 3, it will never break. Just you can draw or take one graph sheet, just to how to construct the graph of this function, then you will understand what we are doing here, what we are getting here. Clear? Therefore, I can write left limit is equal to right limit is equal to value of the function. Therefore, function function f is continuous at x equal to minus 3. Before minus 3 we determine there is no break at that case. Everywhere it will be continuous. Exactly at x equal to 3, there is no break. Now where we should check? After minus 3. After minus 3 to infinity is not given. After minus 3 to 3 has given. After minus 3 to plus 3, whether the function will break or not, that we can determine. Here I can write it. Case number 3, at C belongs to open interval minus 3 to plus 3. This case, any one arbitrary value I am going to choose from the interval minus 3 to plus 3. Any one value you can choose from that interval. If you substituted in that function, whether you will get the value or not. So that here no need to take left limit and right limit, because they did not split the relation at this place. Limit of f of x as x tending to c. Now I can write limit as x tending to c. F of c means which one we can choose. Minus 3 to plus 3 means minus 2x will be there. So that minus 2x we can write it. Dear student, it is a polynomial. This function domain will be set of all the real number. It is a continuous function. So directly we can substitute. Minus 2 into c is equal to minus 2c. In the same sense, directly we substituted also will get the same value. Therefore, it exists limit of f of x as extending to c equal to limit of how much it is? Limit of, sorry, value of the function we can write here, that is f of c. So this is our required result. What we can write? Therefore, function f is continuous. Function f is continuous at c belongs to the interval minus 3 to plus 3. So, minus 3 to minus infinity we have determined. There is no point of discontinuity. Exactly at minus 3, there is no point of discontinuity. Minus 3 to plus 3, there also there is no point of discontinuity. Now, we reached to 3. At exactly at that place 3 we can determine. Okay. Next case, case number 4. That is fourth one. At c is equal to 3. C is equal to 3. Just to look at the question, 3 means left deleted neighborhood of 3, you have one relation. Right deleted neighborhood of 3, you have another relation. So at this case, what we can do? Compulsory we may find left limit as well as right limit. So that left limit is equal to limit of f of x as x tending to 3 minus. So now we can choose the function limit as x tending to 3 minus. F of x means how much we have? Minus 2x. So it is a polynomial function. Directly we can substitute. Hence we will get it minus 6. In the same sense, we should find right limit. This is the limit of f of x as x tending to 3 plus that is the limit of, what is f of x at this case? Right deleted neighborhood of 3 I'm going to choose, means at this time I can choose 6x plus 2, that is 6x plus 2. This relation x tending to 3 plus. Tell me now, 6x plus 2 is also a polynomial function. It is also continuous everywhere. So direct method I can take, that is 6 into 3 plus 2. How much it is? 18 plus 2 will be 20. Here we can observe that left limit is not equal to right limit. We understood that left deleted neighborhood we are getting 6 like that. Right deleted neighborhood we are getting like 20. Like this break we can see in that graph where it will break exactly at x equal to 3. Therefore, what we can write? The function is not continuous, is not continuous at at x is equal to 3. At x is equal to 3, the function is continuous at x is equal to 3 because their function will break. This can be, we can observe by constructing the graph also. Next, the third case, greater than 3. Up to 3 we reached. Next we should go for greater than 3. The last case, that is fifth case, at c will be greater than or equal to 3. So here no need to take left limit, right limit. First definition is enough because here there is no splitting in their input. Limit of f of x as x tending to c. C means any one value 3 to infinity. Any one value from 3 to infinity. Limit of f of x is how much? 6x plus 2. Check it. 6x plus 2 more than 3 means. So now I have chosen 6x plus 2. Okay, this is x tending to c. Substituting here 6c plus 2. So now f of c also the same thing, that is 6c plus 2. It indicates that limit of f of x as x tending to c is equal to f of c. Therefore, function is continuous at c belongs to the open interval 3 to infinity. What's your final conclusion? Final conclusion will be what? That is how much your final conclusion. Therefore, given function f is not continuous at x is equal to 3, or alternatively, or function f is continuous at x is not equal to 3. X is not equal to 3 means remaining value we may consider all the real numbers. Understood? This is the one problem. So now we have completed the question number 7. F of x is equal to modulus of x plus 3. If x is less than or equal to minus 3, minus 2x, x will be greater than minus 3 but less than 3. 6x plus 2, x is greater than or equal to 3. According to their domain, we have to determine whether the function is continuous or not. Let us see about next question. The next question would be, the next question is, already we know that modulus x divided by x, it is an sinum function. Dear student, in class 11 we learned that sinum function graph sinum function graph, that is open circle like that and open circle like that. It means that open circle indicates that that point is not included in our collection. Look at this one. Uh, there are two types splitting. I will take it. X will be less than 0 is one nature. X will be greater than 0 is another nature. X equal to 0 will be some other nature. X is less than 0 means the function is continuously moving everywhere, and x will be greater than 0 means here also the function is moving everywhere, but at exactly at x equal to 0 there is a break in that graph. Understood? So now here just mathematically I'll prove that without graph. F of x is equal to modulus x divided by x 0 here if x is not equal to 0, comma, if x is equal to 0. It means that when your input is other than 0, that time y is equal to, you may choose the relation modulus x divided by x. When exactly your input will be 0, that time you can choose at x is equal to 0. So now in another way also I can write the definition. Already we know that modulus x by x, that will be x divided by x, because modulus x will be a one absolute function. So when our input will be greater than 0 or equal to 0, the time this mod x will be x, and x will be less than 0, this modulus x can be written as minus x by x, and exactly x equal to 0 0, because we learned in previous class this is plus x, x will be greater than or equal to 0, minus x, x will be less than 0. This is a splitting of modulus x. Now, these two I will take. X and x will cancel. It will be 1. Hence, x will be greater than 0. Minus 1, x will be less than 0. 0, exactly x equal to 0. Now we should go by exactly at x equal to 0. Actually, x less than 0, x greater than 0, and x equal to 0. Like this, we have to determine the function is continuous or not. What is our case number 1? At x, c we can take at c which is less than 0. C less than 0 means 0 to minus infinity. Our function will break or not, that we can check it. That's why first definition I will take, limit of f of x as x tending to c is equal to limit of f of x. F of x means which value I can choose, that is minus 1. That is minus 1 as x tending to c. Answer will be minus 1. Hence f of c, that time also minus 1. Therefore, limit of f of x as x tending to c is equal to f of c. What did you understand here? The function is continuous at c less than 0. That conclusion you may write it. And second case, at x equal to 0 or c is equal to 0, that c only becomes 0. That time what? Less than 0, right, greater than 0 means in left deleted neighborhood and right deleted neighborhood they have defined the function, so that I can write it left limit. That is, left limit is nothing that limit of f of x as x tending to 0 minus, this is the limit of f of x. F of x, what we can choose? Input will be minus 0.001. At that time, relation will be minus 1. X tends to 0 minus. Limit of constant is constant. In the same sense, right limit we can choose. Right limit is nothing that limit of f of x as x tending to 0 plus is equal to limit of f of x is how much? That will be plus 1. 0.001 means we can choose the relation 1, that is x tending to 0 plus. The time it is 1. Hence f of 0, exactly 0 means what we can take? That is also 1. Therefore, left limit is equal to right limit is equal to value of the function. Here too we can write it, the function is continuous at x equal to 0. Just you may write the conclusion, the function is continuous at x equal to 0. 0 to minus infinity is continuous, exactly at 0 is continuous. The last case will be greater than 0. At x will be greater than 0. Greater than 0 means 0 to infinity, whether the graph will break or not. That we can check it. Already we know that it is continuous, but here we have to prove by limit method. That is limit of f of x. That c I can take. Limit of f of x as x tending to c. Limit of f of x. F of x means 1, because c will be lies between 0 to infinity. That type one relation we have, x tending to c, that is 1. Hence f of c will be how much? That time also 1. Therefore we write limit of f of c, f of x as x tending to c is equal to f of c. So before 0 function is continuous, after 0 function is continuous, exactly at 0 function is continuous. So this function will be continuous everywhere. What we can write? Therefore function is continuous at x belongs to R. In real number, the function will be continuous. Exactly at 0, what did you get? Left limit is -1, right limit is +1. Here, left limit is not equal to right limit. If we written wrong, just we write it. Left limit is not equal to right limit. The function is not continuous. Function is not continuous. Sorry, here something is missing. Function is not continuous at x is equal to 0. That only we can write it. The function is continuous at x belongs to R minus set containing element 0. Except 0, everywhere the function is moving continuously. Okay. In today's class, some 2-3 problems we have done, and this question is also similar type. That will be x divided by modulus x by x, and this question will be x divided by modulus x. Their points are different and here points are different. Just you have to check it. Take it homework this question. Also this question and question number 10 as well as question number 11 and question number 12. These question will be very and very simple because the relations they have given in polynomial form. That's why these questions I am giving you homework by before 5 p.m. You have to submit all these questions answer. There are 3 questions I'm giving you. Once again, I'll repeat. The question number 9 as usual, similar type. Question number 10, polynomial relation, very easy. Question number 11 also polynomial. Question number 12 also polynomial relations we have. These 4 questions answered by 5 p.m. you have to submit me. Okay. We'll continue these remaining problems next class.